I'm going to demonstrate writing a piecewise function given a real-world scenario, and I'm also going to graph it. So I've made a table to help us organize the information. If you want to pause the video so you have a chance to write down the question in the table, go for it. So we've got this 100-mile triathlon where David swims 2 miles in 1 hour, bikes 80 miles in 4 hours, and runs 18 miles in 3 hours, which means we're going to have 3 different pieces in this piecewise function because there's 3 different activities with 3 different rates. So first, we're going to fill in the chart, given the information in the question, and then if you know anything about how time, distance, and rate are related, we're going to end up using that equation. If you don't know it, it is distance equals rate times time, or DIRT. And so if you wanted to figure out the rate and you're given the time and the distance, you can rearrange this equation where rate is equal to distance divided by time. So if you wanted to pause it to figure those out yourself, go for it. For swimming, we're doing distance divided by time, which would be 2 divided by 1, which means he's going 2 miles an hour while swimming. For the biking, same thing, distance divided by time, you would find that he's going 20 miles an hour. And then running, again, dividing, you end up with 6 miles an hour. So what I like to do with these word problems with piecewise functions is fill out an XY chart. I really like to do that first. Now that I have my rate, it'll be a little easier to do that. So in my XY chart, X is going to represent hours and Y is representing distance. So for hour 1, or after 1 hour has passed, you need to figure out how far he has gone in total. The first one is always going to be the easiest. So he started swimming, he only did it for an hour, and he swam 2 miles. So after 1 hour, he's definitely gone 2 miles. They gave it to us in the question. Now, again, the first one should be the easiest one. If no time has passed, you've gone 0 miles. And then after 1 hour, you've gone 2 miles. So the slope of this line is 2 because slope and rate are very related to each other. They basically mean the same thing. So the slope of this first piece of our piecewise function is 2 because that's the rate. And we know that the y-intercept of this first piece is 0 because if no time passes, you don't go anywhere. So the y-intercept would be 0. So the first piece of this function is y equals 2x. The remaining pieces take some more work. Not necessarily more difficult, they just take more work than what I just did with that one. So for the next 4 hours, he's biking, which means hours 2, 3, 4, and 5. If he's going 20 miles per hour, that means you are adding 20 miles for the next hour of this triathlon. And in the next hour, he's biking. So for hour 2, you take the 2 hours that he's already swam. You need to remember that whatever's happened so far needs to be included in the next hour. So he's already swam 2 miles, plus if he biked for 1 hour, he would have gone 20 miles because it's 20 miles per hour. So the total distance after 2 hours would be 22. And you need to do this the same way for the rest of the chart. So after hour 2, he's gone 22 miles. Once you get through hour 3, he has biked again for another hour, adding another 20 miles to our distance. So we take the 22 miles from the previous hour and we add another 20 miles to that because you're biking at 20 miles per hour. So he bikes for a total of 4 hours, which means we're going to have to do this a total of 4 times. In the next hour, you're adding another 20 miles to the previous 42, giving us 62 miles. And then once he's gone 62 miles, he bikes for 1 more hour, adding another 20 miles, which means he's gone a total of 82 miles. So that's the biking. That will be the second piece of our piecewise function, which we will figure out later, the actual equation of it. For the final 3 hours, he runs. So remember, he's already gone 82 miles. If he's running at 6 miles per hour, in the next hour, he will have ran 6 miles on top of the 82 miles that he's already ran. So we must add 6 to the previous 82 to give us 88. And then we're going to do the exact same thing for 7 and 8. So add another hour, we add another 6 miles, add another hour, we add another 6 miles. And that's how we reach the 100-mile triathlon. Because notice in the beginning of the question, they said it was a 100-mile triathlon. So we should end up with 100 at the end of this after 8 hours. Once I have my XY chart filled in, I like to graph my points. So this is what it will look like. Very slow computer today. Makes me super happy that I can't scroll down all the way. Okay, so this is what it would look like. We had that first little piece where he swam. He just swam for 1 hour and he went 2 miles, that's it. The next piece went from hour 1 to hour 5, and then after 5 went from 5 to 8. So hopefully your graph looks something like that if you decided to try to graph it on your own, which I hope you did. Now we need to figure out the equations. So like I said earlier, the first piece is usually the easiest because we know what the y-intercept is. With the next 2 pieces, we do not know their y-intercepts. If I was to extend this green part of the graph, it's going to hit the y-axis at some point, but I don't know when. Same thing with the red. If I were to extend this line with the same slope, it's going to hit somewhere around here, but I don't know what its actual value is. So we can't just depend on y equals mx plus b. We're going to have to use point slope form. I'm going to start with biking. We already know swimming is y equals 2x. Biking, the rate is the slope. So the rate was 20 miles an hour, which means the slope is going to be 20. And what we're going to use is point slope form, like I said, which is y minus y1 equals m times x minus x1. And you can use whatever point you want for x1, y1, as long as it falls somewhere on the green part of your graph. I'm waiting for the slide to change because it's a slow computer day, of course. Trying to scroll down. There we go. So the slope is 20, like I said, because we're biking at 20 miles an hour. And I'm going to go ahead and use 2, 22, which was this point. You could use any of these points along this second piece, though. So if you want to pause the video and try this yourself, plug in your slope and your x1, y1, and then go ahead and convert it to slope-intercept form to figure out the equation of this second piece. So here's my work. Plug in everything where it belongs, distribute the 20, add the 22. You end up with y equals 20x minus 18. So this green part of the graph is y equals 20x minus 18. As you can see, I would have had no idea the y-intercept was negative 18. That's why we had to use point slope form. We're going to do the exact same thing for running, which is the third piece. And so we're going to use point slope form again. Just like I did before, if you want to try it yourself, pause the video and do it. I highly encourage you do it since I just showed you how to do it with the biking. So running, I'm going to use Obviously, the slope is 6. You have to use that as well. I'm going to use the 0.6 comma 88. You can use whichever point you want as long as it is on this red line. Doesn't matter which one, as long as it's here somewhere, you can use it with the slope of 6. So if you haven't already, pause the video, try it yourself, plug it into point slope form and see what you get. And I will show you what I get eventually. So you plug in everything and distribute the 6, add the 88, you should end up with 6x plus 52. So this is another one where I didn't know the y-intercept was going to be 52. There's no way I would know that by looking at the graph. So you need to make sure that you always use your point slope form. The last thing we're going to do is write the piecewise function. That's the last thing we need to do here. You're going to write y equals and then list your 3 equations. And then you also have to figure out their domain restrictions. So I encourage you to figure that out yourself first before I get into it. But here I go. When he was running, it was, or no, not running, sorry. When he was swimming, that was from the beginning. So 0 hours had passed until 1 hour. So only between 0 and 1 hours was he swimming. Then after he swam, starting right after he hits hour 1, he's going to bike until he hits hour 5. Then after 5, he runs until hour 8 or the end of hour 8. So I'm going to show you my piecewise function with the correct domain restrictions. The first equation was y equals 2x. That was his swimming. He did that between 0 and 1, and I'm going to include both of those numbers because after he's through with hour 1 is when he starts biking, and that equation had 20x minus 18. I'm not including 1 because I already included it up here. You're not allowed to include the same number twice in your domain restrictions. Then we get to hour 5. And once he has gone through the full 4 hours and he hits hour 5, he then starts to run immediately after finishing those 4 hours. So I'm including 5 here, but I'm not including it here. Again, you can't include the same number in 2 different functions or 2 different equations in your function. Finally, he runs until 8, and we're stopping at 8 because it was an 8-hour triathlon. So there's no point in going past 8 hours.